Today we're going to be focusing on the third method to solve quadratic equations, which is factoring. Now you guys already know how to factor and you did an amazing job with it in the last chapter. So there's nothing new for today per se, just some reminders, and I chose some examples that might help refresh your memory to do an awesome job on that practice form for tomorrow. So today we're factoring, again, quick 4 examples, quick 4, just try it on your own and you'll be done for today. So the first example I chose to do from the notes, I chose because A is 1. So this one I'm just going to start off with a simple X puzzle, and I'm looking for what two numbers multiply to 15 and add to 8. So I know that's 5 and 3, because 5 times 3 is 15. 5 plus 3 is 8. Now when A is 1, I don't need to worry about the split method. I can just go ahead and make my two binomials set equal to 0. So I can use those factors to say x plus 5 and x plus 3. Now the zero product property tells me that I can go ahead and set both of those binomials equal to 0. So when I solve, I end up with -5 and -3. Now if you're a visual person like I am, what those two numbers mean is that when I graph this quadratic equation, the parabola is going to cross the x-axis at -5 and -3. So there are two solutions to that quadratic equation. And remember, these can be called solutions, they can be called roots or zeros or x-intercepts. They all mean the same thing. I'd be done with that one, and A equals 1 is an easy one. The next one I chose because A is negative. And with this one, I could do the split method and do -1 times -45, but that split method is a lot more complicated. And what I like to do here is factor out the -1. And when I factor out a -1, all of my signs just change in the trinomial. They all just change to the opposite. Now I have an A that is 1, and I don't need to worry about the split method. I can just go right to my x and say 45 and -14, and I'm looking for what two numbers multiply to 45 and add to -14. And I know that's -9 and -5. If I multiply them, I get +45. If I add them, I get -14. And again, because I factored out that -1, I don't need to worry about the split method. I can just use -9 and -5 in my binomials and set them equal to 0. Now when I solve each of these equations separately, I end up with +9 and +5. And you would be done with that quadratic equation. The next example I chose for you, I chose because A is greater than 1. Now when A is greater than 1, that is when I need to do my multiplication of A times C for the top. So when I multiply 6 times -12, I end up with -72. And I need two numbers that multiply to -72 and add to -1. Those two numbers are going to be 8 and -9. 8 times -9 is -72, and 8 plus -9 is -1. Now because A is not 1, I need to go ahead and use the split method here. So I'm going to rewrite this quadratic, but instead of writing -1k, I'm going to write 8k minus 9k. They're equivalent. Say 6k squared plus 8k minus 9k minus 12 equals 0. And again, this here is just another way to rewrite -1k. Now I need to split. And I'm going to pull the GCF out of each side. So on the left-hand side, I see I can pull out a 2k. And what I have left on the inside is 3k plus 4. And now I need to look at the right side and pull a GCF out, keeping in mind that I need my binomials to match. So what I can pull out over here is a -3, so my signs are going to be changing and match. And I'm left with 3k plus 4 on the inside. Now I have two binomials. They are 2k minus 3. Remember, I got that from the GCFs that I pulled out. And I also have the binomial that I was left with. That's a twin, they're matching. So 3k plus 4, and that equals 0. Now I can set each of those equal to 0 because of the zero product property. So I have 2k minus 3 equals 0, and I have 3k plus 4 equals 0. And be careful here, don't mess up your signs. Make sure you show your work so that you don't lose a negative and make a silly mistake after all that hard work. Here I would add 3, so I'm left with 2k equals 3, and I divide by 2 to be left with 3 over 2. And for my one on the right, 3k plus 4, I subtract 4 on both sides, so I'm left with 3k equals negative 4, and I divide by 3, so I'm left with negative 4/3. Now, if you were to graph that, you'd be able to estimate your answers, but you would not be able to get an exact answer. So this is a good example that factoring is going to work out perfectly for. A graph would show an approximate answer, those approximate roots, but it's not going to give me an exact answer. The last one I chose is factoring out a GCF. And in the notes, it says that you need to make sure it's set to standard form before you do anything. So I need to set this equal to 0. You guys have been doing an awesome job with that. I would do that by adding 6m to both sides. And I'm left with 3m squared plus 6m is equal to 0. Now I have it in standard form, and I can factor out a GCF. In looking at this, I can pull out a 3m, and I'm left with m plus 2. Now here's where I can split and set both equal to 0. 3m equals 0, and m plus 2 equals 0. And when I solve, I get 0 as a root, and I also get negative 2. So that's it for the examples today to refresh your memory. I have a few try it on your own, and I also posted my notes so you have access to those to look at the work a little closer if you need it. For the try it on your own, I have 2 up right now if you could write them down. And I'm also going to go down a little bit to show you the 2 more. So there are 4 total try it on your own. Pause the video, do them on scrap paper, write them out in your notes. Some of you are gluing them in your notebooks still, which is so awesome. You would definitely be able to use your notebooks next year. And I'm going to back up to show you the solutions. For the first one, you should get 2/5 and 1. The next one should be negative 4 and 18. Followed by 0 and 8, and finally negative 8 and 8. Hopefully that was a helpful refresher for you guys, and I hope to see you guys later on the Zoom. Bye.